Hello, hello, hello. So, I was thinking that I'm very interested in machine codes, and I want to find out how to run pure machine code directly without containers like exe. I need to hello world to how machine code actually works. Necessary cookies only. Through Windows, exe and Linux ELF near machine code, but it is not pure. How can I write pure machine code, assembly or machine code? You can write pure machine code without assembly. What do you need to run the test? What you need to run the test? Linux 86 or 64. In my case, I'm using a 1264. Moves the value 66 into EAX register. Okay. Where is that? Uh, I've been lately really interested in machine code, and I'm finding a way to write pure machine code. Execute. Okay, okay, I am not interested now. And actually, I was also interested in GSM systems because what I have felt that when because for a long time I have felt that whenever you are talking to someone, for example, if let us think that person A called person B through mobile, through sim, through cellular network, right? And that person A calls and sends some radio signals, including some of the possibly the data whom to call, and then that is sent to the that is broadcasted in area in the atmosphere, right? And that broadcasted signal is picked up by nearest tower, that is converted into radios to electrical signals sent to maybe exchange whatever that is, and then it routes to the tower where the person B is, right? And then it sends a signal for person B that there is someone calling you, and then person B replies, and then person B, then person A, then that information is being sent to person A, and then person A's mobile phones and person B's mobile phone connects through radio signals, going through electrical signals and everything that. I was thinking that how can it be done, right? I was thinking that the when person A sends a signal to the when person A broadcasts signal that I want to call this person, then that should not be encrypted, right? Because if it is encrypted, that that should be encrypted, but that encryption standards not must be that much hard to decrypt, because if it is that hard to decrypt, then it wouldn't be able, then the exchange will not be able to decrypt. I don't know what I am saying, is that true, is that not. That's why I want to learn about GSM and see if there is a way, there is a way to bypass the encryption, and somehow can we get the data, can we live get the data, what is going on, what one is saying on his phone. I know this is illegal, I know this is illegal, but if even I did it, I will do it on my phone or my parents' phone, because with taking the permission, obviously. That's why this is for educational purpose, and probably it won't happen. Let me read it. Global System for Mobile Communication (GSM) is used by more than 800 million end users spread across 190 countries, which represents around 70% of today's digital wireless market. How it works in GSM, the geographical area is divided into hexagonal cell. Oh, SIM contacts mobile station, base subsystem BTS, BSC, MSC network subsystem. Okay. Initially, GSM used two frequency bands of 25 megahertz width 890 to 9115 megahertz. Okay, this is frequency band. No. Band up for uplink and 9 for downlink. Oh, 200 kilohertz width. Okay. 25 megahertz band into 124 channels, each having 200 kilohertz width, and remaining 200 kilohertz is left unused as a safe band to avoid interference. Oh, means first 200 kilohertz band, and then another, then 1 200 kilohertz. Means one band of 200 kilohertz is left, and then the next one is used to avoid interference. Heck of a job.
ओप्पो एआई बोल ना ब्रो यार परफेक्ट पिक्चर पर ये लबर्स को उड़ाना
G'day YouTube, welcome to my channel. It is Wednesday the 9th of March 20.
It's a packet analyzer, right? Go away. Oh, okay, it's a lot of.
23.
Actually, I want to really show you something which is quite good actually. Making neural networks in not MATLAB, not Python, not TensorFlow, in Minecraft. Oh, mad bad things. This person really made it.
I made a fully working neural network in Minecraft. You can draw a number on this drawing pad and it'll tell you what you drew. This is the story of how I made this project, from researching to running simulations to building all the redstone. I hope you enjoy.
Like, wow.
This story starts a few years ago when I was taking a machine learning class at university. On the first day of class, the professor showed us some basic neural networks and how they could learn things like humans do. And as someone who did redstone, I wondered if it was possible to make a neural network in Minecraft. I mean, how cool would it be to build something in your world and watch it learn? Especially if it could learn something complex, like image classification. So later that day, I went on YouTube to see if anyone else had done it before. To my surprise, almost no one had. At least, not with just redstone. There were a few people that did it with command blocks, but I could only find one person who built a redstone-only neural network, Yannick Kilcher. After watching the video, I was really impressed, but at the same time, I was a little bit disappointed. Not in Yannick, he did a great job, but just in the size of the network. If neural networks are already this big and complex for just a few neurons, then making something like an image classifier seemed completely out of reach. So I scrapped the idea and I just made other kinds of projects for my channel. But then, in the summer of 2022, this video popped up on my recommended, and I immediately clicked on it. A team of people made a convolutional neural network, and they used it to recognize handwritten digits. You could draw a number on the screen, and the network would tell you which number it thinks it is, along with a confidence value. Suddenly, my opinion on neural networks completely changed. Clearly, it was not only possible to do cool stuff with them, but also keep them in a relatively small footprint. Now, for better or for worse, I'm a very competitive person, so I quickly became fixated on making an even better neural network than this. I wanted to make a handwritten digit recognizer that was faster and had better accuracy. Whether this was possible or not, it didn't matter. My competitiveness meant that I was about to spend a lot of time trying to make this happen. There are lots of different kinds of neural networks, so first I had to decide which type of network to use. After looking at some handwritten digit networks online, it seemed like most of them either used a multi-layer perceptron or a convolutional neural network, which is what the team used. Both MLPs and CNNs can get pretty high accuracy on handwritten digits, so I actually decided to go with an MLP because it seemed easier. This was a bold choice, considering the team didn't do this, and they clearly knew what they were doing, but I just had a gut feeling that an MLP would be better suited for redstone. Now, if you haven't seen MLPs before, 3Blue1Brown has an absolutely incredible video on them, and it's on handwritten digit recognition too, so I highly recommend watching it, but I'll give a shorter explanation here too. An MLP is a function with input and output. In my case, the input is all the pixel values of the handwritten digit, 0 being black all the way to 1 being white, and the output is 10 numbers, representing the confidence the network has for each digit. If you put in the pixel values of this image, for example, a smart MLP would output a high confidence for 3 and a low confidence for everything else. But for simplicity, consider an MLP with just 2 inputs and 2 outputs. Inside the MLP, there are neurons and connections between the neurons.
And gap.
Every connection has a weight, which is a number that
Every gap.
represents the strength of that connection. And every neuron has a bias, which represents how likely or unlikely it is to fire. When you input something to the network, like 1 and 2 for example, they get sent out by the connections and multiplied by the weights. Then, for each neuron in the next layer, all the numbers that arrived get added up, and the bias of each neuron gets added as well. Then these neurons send their values to the next layer, and the process repeats itself. Every column of neurons is called a layer, and these layers have special names. The first one is the input layer, the last one is the output layer, and anything in between is a hidden layer. In general, you can have as many hidden layers as you want, and within any layer, you can have as many neurons as you want. So there's a huge variety for what an MLP can look like. In the case of handwritten digit recognition, the input layer has as many neurons as there are pixels in the image, and the output layer has 10 neurons. Now, as I've described the network so far, it's just image, and the output handwritten digit recognition, the input layer has as many neurons as there are pixels in the image, and the output layer has 10 neurons. Now, as I've described the network so far, it's just doing a bunch of multiplications and additions. That's great, but it also means that if you're good at linear algebra, you can reduce the entire network down to an equivalent network with just an input and output layer. So there's actually one more thing an MLP does. After a hidden layer outputs its numbers, an activation function is applied before passing it along. One of the simplest activation functions is called rectified linear unit, or ReLU. ReLU just says if it's negative, set it to 0. Otherwise, don't change it. So let's apply a ReLU to the output of the hidden layer, and as you can see, the negatives become 0. Then they get passed along. Another way to think about activation functions is that they're kind of analogous to a real neuron. The output is 0 until you hit a certain threshold, which makes the neuron fire. So that's how an MLP is executed, but how does it actually learn to recognize digits? Well, it has to be trained. In other words, it has to learn the weights and biases that give the best accuracy. This is typically done by showing the network tons of examples and using an algorithm called backpropagation to continuously update the weights and biases. And hopefully, after showing it lots and lots of examples, you can then show it a brand new digit and it'll make a prediction based on what it's learned. Now that I had a better grasp on MLPs, I created a plan for the rest of the project. First, I wanted to simulate and train the entire network in Python. That way, if the redstone had an issue later, I'd have a reference to compare it to. Then, I wanted to build it in Minecraft and import the weights and biases from the code, so the redstone would only execute a forward pass through the network. In Python, I started by importing the MNIST dataset, which has thousands of examples of handwritten digits. Every example is 28 by 28 pixels, and it's labeled with the correct number. Then I used a package called Keras to build the network. I made the input layer 784 neurons, one for every pixel in the image. And then I didn't know how many hidden layers I was going to need, so I started off with just one hidden layer of 32 neurons and a ReLU activation. And then I made an output layer of 10 neurons. Once that was done, I used this code to train the network. And after testing it, it got a really high accuracy of 96%. Then I continuously reduced the number of neurons in the hidden layer, seeing how it affects the accuracy. And I ended up finding a sweet spot at about 10 neurons, which still gave pretty good accuracy, 92%. And now I had an actual structure for my network. 784 input neurons, 10 hidden layer neurons, a ReLU, and 10 output neurons. But this is when I ran into my first big problem. The images in the MNIST dataset are grayscale, and there's no easy way to show a grayscale image in Minecraft. I mean, technically there is, but how would the player even draw one anyways? The best you can do is draw an image on redstone lamps, which are only on or off. So using this code, I made all the pixels in the dataset snap to either black or white, depending on which one they're closer to. I retrained the network, and the accuracy was still 92%. However, I found another big problem. The weights and biases are stored internally as floating point numbers, which are really difficult to work with in Minecraft. In fact, almost no one does it. Most people just work with integers. I tried rounding all the weights to the nearest integer, but because of how precise they were, this lost a ton of accuracy. But then, I had a pretty good idea. I decided to multiply the weights by 100 and then round them. This works because the exact value of a weight doesn't really matter. What matters more is how the weights relate to each other. So this strategy allowed me to get more precision, convert them to integers, and keep their relative relationships. I tested the network again, and it still got decent accuracy, 83%. Obviously it's not amazing, but it was still better than my self-imposed competition. With the simulation working, it was time to start building the redstone. I started with the drawing tablet, which would allow the player to draw a number by moving around on a platform. Luckily, I had already built this exact thing before in my Redstone Paint program. It used tripwires and string to detect where the player was standing and sent that information to the screen. So I ripped it out of the paint build and I modified it to be 28 by 28 pixels. I tested it out and it worked beautifully. When I sped up the game using Carpet Mod, I was able to draw in nearly real time. I also explored some other options like pressure plates and throwing snowballs at the screen, but it seemed like nothing could beat the elegance